All right, let's talk about something that's probably driven you crazy at some point. A mysterious signal failure that just tanks your project. You are definitely not alone. So today, we're going to break down industrial cable separation. We're going from the dense, official standards all the way down to what you actually do on the skid, to make sure your signals are clean and your project actually works. Let's jump in.
I mean, if you're an engineer, if you're a tech out in the field, you know this feeling. The project's almost done, you're ready to pack it up, and then a critical sensor reading starts jumping all over the place, or a control signal just vanishes. It is one of the most maddening things, right? You've checked every connection, you've swapped out the device, and still nothing. So what is actually happening here?
Well, the culprit is totally invisible. We're talking about electromagnetic interference, or EMI. The easiest way to think about it is just electrical noise. It's what happens when you run those big, beefy power cables too close to your delicate little signal cables. The power cable basically screams at the signal cable, inducing these unwanted currents that corrupt your data, make your equipment act possessed, and can even create some really serious safety hazards. Yeah, getting this wrong isn't just a minor mistake, it's a critical failure just waiting to bite you. Okay, so how in the world do we fight this electrical noise? The good news is we don't have to guess. There's a whole set of industry standards out there that are basically our playbook for defeating EMI. And look, don't think of these as just boring rules you have to follow. Think of them as your absolute best defense against that signal chaos.
So in most tech docs, you're going to run into three big ones. You've got IEEE 518, that's kind of the master guide for EMI. Then there's IEC 60204-1, which is all about the safety side of things. And finally, especially for my oil and gas folks, there's API RP 552.
So let's kick things off with IEEE 518. This is really the most detailed, precise reference we've got. What it does is it sorts all cables into 4 levels. It goes all the way from your super sensitive analog signals, think vibration sensors, down to those massive high-power cables. And why does this matter? Because this classification is the key. It's how we figure out the exact distances we need to keep them apart to stop that noise.
Okay, next up is IEC 60204-1. This one's a huge deal, especially if you're working with industrial machinery in Europe. Its whole reason for being is safety and making sure things work correctly. The big takeaway from this one? You must physically separate your power circuits from your control circuits. Why? To stop malfunctions that could lead to some really, really dangerous situations.
And hey, for all of you working in refineries, petrochemical plants, this next one's for you. API RP 552 is your rulebook. It was written specifically for these tough, electrically noisy places. It flat out mandates that you separate instrument cables from electrical cables, especially around things like compressor skids, where EMI is just a massive problem.
All right, so we've got the standards, we know the rules, but let's be real. How do you take all that theory and actually apply it on a cable tray that's already packed? That's where this next part comes in, the distance matrix. This is your practical, everyday roadmap.
Okay, hang on. Before we even look at a single number, there is one absolutely critical assumption here. This whole thing, this whole roadmap, it only works if your signal and instrument cables are shielded, and if those shields are properly grounded. If you don't do that, all these distances we're about to talk about, totally meaningless. This part is non-negotiable.
This table right here? This is where we turn all that complicated standard speak into simple, actionable steps. Let's just walk through a really common one. See that first row? You've got a low-voltage power cable next to a sensitive instrument cable. With nothing between them, you need a good 30 to 50 centimeters of space. That's a lot, but just add a simple grounded metal divider and boom, you cut that distance in half, down to just 15 centimeters. Or look at the next row, a 24-volt control cable next to a power cable. With that divider, the required distance drops all the way to 0. This is literally your cheat sheet for laying out a cable tray.
So having the chart is great, but actually mastering the installation in the real world, especially when you're crammed into a tight space like a skid, that takes a few more tricks up your sleeve. These next few things are what I call the golden rules of execution. This is what separates a pretty good installation from a truly great one.
Look, sometimes you just can't avoid it. Your cables have to cross paths. When a signal cable has to cross a power cable, there is one single critical rule you have to follow. They must cross at a perfect 90-degree angle, a right angle. Doing it this way minimizes the magnetic field that jumps between the cables. That's the thing that actually carries the noise, so it keeps your signal clean. Just burn this number into your brain, 90 degrees.
This right here just shows you the incredible power of one simple piece of metal, the divider.
Over on the left, you see you need that huge air gap, right? But on the right, you just slide in a grounded metal partition and it acts like a shield, literally soaking up that electrical noise. When you're stuck in the tight confines of a skid where 30 centimeters of free space is a fantasy, this little divider becomes your absolute best friend.
Okay, last thing. Let's do a quick rapid-fire checklist to make sure your work is truly pro-level. First, ground your cable shields on one side only. Usually that's at the control panel. This is so important because it prevents ground loops, which are these nasty little currents that can create their own noise. Second, for your most sensitive stuff, I'm talking vibration probes, things like that, use steel conduit or a solid bottom tray with a cover. Give it maximum armor. And third, check your dividers. Make sure they're tall enough to actually reach the top of the highest cables in the tray, otherwise they're not doing their job.
So you see, cable separation isn't just some boring item on a checklist. It's about actively defending the integrity of your entire system. It's what guarantees reliability, proper function, and ultimately, safety. So the next time you're out on a job site, just take a second, look closely at those cable trays, and ask yourself, is this project really safe from that invisible enemy?